Let us see the statement of the example. A venturimeter with 15 mm throat ID is installed in a pipeline of 25 mm ID for measurement of flow rate of water. In this first sentence, we have given the throat inside diameter and pipeline inside diameter, and this venturimeter is used for the measurement of flow rate of water. The pressure drop across the throat and upstream of meter is 10 cm of mercury. The pressure drop is given 10 cm of mercury. Manometric fluid is mercury. Here given that the manometric fluid which is used in the manometer is mercury. Venturi coefficient is 0.98. Coefficient of Venturi CV is given 0.98. Calculate the flow rate of water in the pipeline. We have to calculate the flow rate of the water. Another given data are density of water equal to 1000 kg per meter cube and density of mercury 13600 kg per meter cube. So these are the given data, and from this much given data we have to calculate the flow rate of water in the given pipeline. So let us start to solve this example. We have already studied the flow equation which is used to calculate the flow rate in case of venturimeter. So write down the equation which is used to calculate the flow rate. This is the equation, or I can say flow equation, which is used to calculate the flow rate in case of venturimeter. Q is equal to CVAT upon under root of 1 minus beta raised to 4 into under root of 2G capital delta H. We all know what the terms are described. CV is coefficient of venturimeter, AT is area of throat, beta is diameter ratio, capital delta H which is the head, and capital delta H is what? Small delta H rho m minus rho upon rho. We have already studied that in our theory part. First, list out the data which was given in the statement. See, these are the data. Q, which is volumetric flow rate in meter cube per second, that we have to calculate. CV, coefficient of venturimeter, given 0.98. AT is cross section area of the throat. Beta is diameter ratio, diameter of throat upon diameter of pipe, which is dt by d, and delta H, capital delta H is pressure drop in meter of flowing fluid. Fine. So these are the terms which is used in the formula to calculate the flow rate of water. Now, area of throat AT is pi by 4 dt square. dt is given 15 mm. We generally follow the SI unit, so we have to convert it into meter. So pi by 4 dt square is equals to pi by 4 0.015 square. When you solve this, you will get the answer of AT is equals to 1.767 into 10 raised to minus 4 meter square. So now we have value of AT, that is cross section area of the throat, which is equal to 1.767 into 10 raised to minus 4 meter square. Now next we calculate the diameter ratio beta, which is the ratio of diameter of throat divided by diameter of pipe. Diameter of throat is 15 mm and diameter of pipe is 25 mm. So 15 by 25, which is equal to 0.6. So now we have beta value equal to 0.6. Now calculate next term, which is capital delta H. Capital delta H is small delta H rho m minus rho upon rho. Rho m is manometric fluid density. Here manometric fluid is given mercury, which is Hg. So capital delta H is small delta H into bracket rho Hg minus rho is our process fluid, and process fluid in this case is water. So rho Hg minus rho H2O divided by rho H2O. Putting the value in this equation, capital delta H is equals to small delta h, and small delta h is given 10 centimeter. So which is equals to 0.10 meter. Fine. So small delta h is 0.1 into bracket. Rho Hg and rho H2O are given in this statement. Rho Hg is 13600 kg per meter cube and rho H2O is 1000 kg per meter cube. So putting all this value in the given equation, delta H is equals to 0.1, 13600 minus 1000 divided by 1000. When you solve this, you will get the answer 1.26 meter of H2O, which is our process fluid. Fine. So now in our flow equation of Q, we have all the values except Q. So putting all the values in our flow equation, so now substituting the values of various terms involved in the equation of Q. So Q is equal to CV, CV is 0.98, AT, AT is calculated, we have calculated 1.767 into 10 raised to minus 4 upon under root of 1 minus beta raised to 4, beta is 0.6. So 0.6 raised to 4 into under root 2G capital delta H. So 2 into 9.81 into 1.26 capital delta H. When you solve this whole equation, you will get the answer 9.23 into 10 raised to minus 4 meter cube per second. So our final answer of volumetric flow rate Q is equals to 9.23 into 10 raised to minus 4 meter cube per second. That's what we had asked to calculate. Fine. So this is the final answer of our exam. So by this way, we can calculate the examples based on venturimeter. In some of the examples, Q is given, you have to calculate coefficient of venturimeter CV. In some of the examples, CV is given, you have to calculate the value of Q, as we have done just now. So these type of examples will be asked in the exam. Fine. Now let us see another example which is of the flow meter of orifice meter. See first the statement of the example. Sulfuric acid of density 1300 kg per meter cube is flowing through the pipe of 50 mm ID. Here in this orifice meter, sulfuric acid is flowing having density 1300 kg per meter cube in a pipeline of 50 mm inside diameter. An orifice meter of 10 mm diameter is fitted in the pipe. So orifice meter having diameter 10 mm which is fitted in the pipeline. A mercury having specific gravity 13.6 manometer is fitted to the system. That means mercury is used as manometric fluid having specific gravity 13.6. Measures differential pressure as 10 centimeter. So differential pressure is given 10 centimeter. Mercury which is used as manometric fluid, specific gravity is given 13.6. Calculate the mass flow rate of acid in kg per hour. Assume orifice coefficient is 0.61. So in this example, we have to calculate mass flow rate of this sulfuric acid. The whole system is given. There is a pipeline in which sulfuric acid is flowing having this much density. Manometer which is fitted to the pipeline having manometric fluid as mercury. Specific gravity is given. Pipeline diameter is given. Orifice diameter is given. And coefficient of orifice is also given. So now first, when we solve the example, first we have written the flow equation of orifice meter. This is the flow equation of orifice meter. We have already derived in theory part. Q is equal to C0A0 upon under root 1 minus beta raised to 4 into under root 2G capital delta H. This is similar as venturimeter. Fine. Now list out the data given. Diameter of the pipeline is 50 mm, which is 0.05 meter. Diameter of the orifice DO, which is given 10 mm, equals to 0.01 meter. Specific gravity of the manometric fluid is given 13.6. So rho of mercury is 13.6 into 1000, which is equals to 13600 kg per meter cube. And density of sulfuric acid is given 1300 kg per meter cube. So these are the data given. Now first we calculate capital delta H. We have given the value of small delta H as 0.10 meter of Hg. That is given in our statement. Now we all know very well how to calculate capital delta H from the given value of small delta H. So capital delta H is equal to small delta H into bracket rho Hg minus rho acid upon rho acid. Rho Hg, that is manometric fluid, rho acid is our process. So capital delta H is equal to small delta H into bracket rho Hg minus rho acid upon rho acid. All the values are with us. Put the value in equation of capital delta H. 0.10 into bracket 13600 minus 1300 divided by 1300. When you solve this, you will get the answer of capital delta H is equals to 0.946 meter of acid. So now we have the value of capital delta H. Now let us calculate the area of orifice A0 and beta value. Beta is diameter ratio. So diameter of orifice divided by diameter of pipe. So 10 by 50 equals to 0.20. So now I have value of beta is equals to 0.20. Coefficient of orifice meter is given in the statement, which is 0.61. So now I can easily calculate area of orifice A0, which is equals to pi by 4 d0 square. So pi by 4, 0.01 square. So when you will solve this, you will get the answer of A0 is equals to 7.854 into 10 raised to minus 5 meter square. Fine. Now we have all the values, capital delta H, beta, A0, C0. Now you have to just put all the values in our flow equation of orifice meter. This is my flow equation of orifice meter. Q is equals to C0A0 upon under root of 1 minus beta raised to 4 into under root of 2G capital delta H. Put all the values. 0.61 into 7.854 into 10 raised to minus 5 divide by under root 1 minus 0.2 raised to 4 into under root 2 into 9.81 into 0.946. When you solve this whole equation, you will get the answer of Q is equals to 2.06 into 10 raised to minus 4 meter cube per second. When you write the unit, you must be careful. We generally follow SI unit, so unit consistency must be maintained. Fine. So now Q value is 2.06 into 10 raised to minus 4 meter cube per second. But this is the value of volumetric flow rate. But we have to calculate mass flow rate in kg per hour. That is asked in our exam. So now I have to convert the volumetric flow rate into mass flow rate. Fine. Q value is 2.06 into 10 raised to minus 4 meter cube per second. Mass flow rate is volumetric flow rate into density. Fine. We all know that mass flow rate of acid is equal to volumetric flow rate of acid multiplied by density of acid. We have already calculated volumetric flow rate 2.06 into 10 raised to minus 4 into density of acid was given 1300. So 2.06 into 10 raised to minus 4 into 1300, you will get the answer of 0.27 kg per second. But the value of mass flow rate will be asked in kg per hour. So convert this kg per second into kg per hour by multiplying it with 3600. So you will get the answer of mass flow rate equals to 972 kg per hour. So my final answer of mass flow rate of acid is 972 kg per hour. I hope this is clear to all. Thank you.